This lesson is on section 6.6, placing figures on the coordinate plane. We can use what we've learned so far about quadrilaterals in this chapter and their characteristics to solve the following kinds of problems. For example, if I give you that this is an isosceles trapezoid, and I tell you that one of the coordinates is at 0, 0, and another coordinate up at the top left is at A units over and B units up, the third coordinate is also on the x-axis, and it's at C, 0. What would have to be the coordinates of P based on the other three coordinates? You have to use what you know about an isosceles trapezoid, because these coordinates, since this one is horizontal, this one has to be horizontal because these are parallel. So the y-coordinate, how high up this point is, would have to be the same as how high up this point is. So the y-coordinate would have to be a b. The x-coordinate would be how far out from 0 it is. In other words, how far is this spot from 0? It's not C units, C is further. We have to figure out what the distance here would be. It would be the same as the distance, if I brought C up, it would be the same as this distance. Well, how much is this distance in an isosceles trapezoid? It would have to be the same as this distance over here. What is this distance over here? This distance is A units over. So to go backwards from C to get back to this point, how much would I have to remove from C? I would have to remove A units. I would have to remove a distance of A. So my x-coordinate would be C minus A. And then my y-coordinate would be B, and those would be the coordinates of point P. So what would be the midpoint of that top line? Okay, that requires us to remember how to find the midpoint. Remember, that's just the average of the two x-coordinates and the average of the y-coordinates. If I was looking for the value of the midpoint, it would still be B units tall. It's the same height as the others. And I would get that simply by taking B plus B and dividing it by 2. That would give me 2B over 2, which would give me B. If you didn't use common sense and you use the formula strictly, then that is how you would get B. For the x-coordinate, it's going to be a little bit different. I would take A plus C minus A all over 2. That would be the midpoint formula for my x-coordinate. Add your x values and divide by 2. When I add A and negative A, they cancel each other out. So I'm left with C over 2, which common sense would tell you that would make sense because half this midpoint would be at the same distance across as this midpoint. Since C is all the way across, C divided by 2 would be the midpoint. And so the coordinates of the midpoint would be C over 2 for my x-coordinate and B for my y-coordinate. If I'm going to find my length of a segment, depending on whether it is a horizontal segment, vertical segment, or diagonal segment, is a little bit different. If it's horizontal or vertical, I can simply count the distance from the beginning to the end. If it's diagonal, then I have to use my distance formula. If I'm finding the length of my top line and my coordinates are at C minus A and B, to figure out what the length of this would be, I would simply take C minus A, that's how far over it is, and I would subtract off A to get to the length of my segment. So C minus A would be equal to C minus 2A. That would be the length of my segment. I didn't have to use the distance formula because it was a horizontal line. I could also look at it in terms of, well, how long is this line compared to this? Well, this line is C, and I know that the length of this line goes in A units on this side and A units on that side. So if I took C and I minused off two A values, that would give me the length of this segment. What would be the slope for a line, specifically this line on the left? I see that in my parallelogram here that my coordinates are 0, 0, QP, R0, and then I'd have to figure out what the coordinates of my other point are. But to find the slope of this line, I need to simply know how far it rises and how far it runs to get the slope of a line. So from 0, 0 to QP, how much do I rise? I would rise P units and I would run Q units. So my rise over my run would be P over Q. That would be the slope of my line. The length of my line, same concept. I would use the distance formula. The difference between my x's would be Q. The difference between my y's would be P. Remember that the distance formula is the difference between your x's squared plus the difference between your y's squared, and then you basically stick them into the Pythagorean theorem. So you take those squares, add them together, and square root them, because the three pieces make a right triangle. The difference between my x's, between 0 and q, is q. The difference between my y's would be the difference between 0 and p, which would be p. So I would square them, q squared plus p squared, and then I would take the square root of that. So the length of this side would be the square root of q squared plus p squared. That would be the length of this segment. To figure out the coordinates of point P in this parallelogram, I would simply have to look and realize, using my characteristics of a parallelogram, since opposite sides are congruent, the length of this side would be r units, so the length of this side has to be r units. If it starts q points over, or q units over, this coordinate would be q plus r for my x coordinate. And then how tall it is, well, it would have to be the same height as this point, so my y coordinate would be p. That is the extent of this lesson. Your homework is as follows.